This is part 4 of 4 videos that cover the material from 1.2. So how to determine the domain and range for a function given the formula. So exclude from the domain any input values that result in division by 0. So you look for places where the denominator might be 0. Exclude from the domain any input values that have non-real or undefined output numbers. Use the valid input values to determine the range of the output values, and look at the function graph and table values to confirm the actual function behavior. So this first one, f of x equals 3x cubed plus x. There are no values we need to restrict or eliminate from it. So everything can be plugged in. And if you recall, a cubic function has a graph like this. This one in particular will not be this graph. It's going to be a little different, but this is the generic. Put this for people reading the notes. So the domain is going to be, do we want this in interval? I'll just do interval. Negative infinity to infinity, and the range is negative infinity to infinity. Now for this next one, we have this x minus 2 in the denominators, so we can't have a 0, so x minus 2 equals 0 when x equals 2. So we have to exclude this. For the rest, everything is good. I mean, everything else will work. So our domain is going to be negative infinity up to 2, parenthesis union 2 to infinity. And now let's look at the range. So this one, if we were to look at the graph of this, it's going to be over here doing something like this. So we're still going to exclude out of here that y equals 0 because it's never going to reach there. So it would be negative infinity to 0 union 0 to infinity. And the next one, it's a square root. So remember, our square root function looks something like this for the generic. So we have 3 plus x has to be greater than or equal to 0. Subtracting 3, x must be greater than or equal to negative 3. So our domain is going to be negative 3 to infinity. And the range, there's no vertical shifting on this, so the range is going to go from bracket 0 to infinity. Now let's talk about the concept of a piecewise defined function. This is a function that's defined differently in different places. So a piecewise function is a function in which more than one formula is used to define the output. Each formula has its own domain, and the domain of the function is the union of all these smaller domains. We notate this idea like this. So formula 1 if x is in domain 1, formula 2 if x is in domain 2, formula 3 if you have that many, if x is in domain 3, and there's no limit to how many formulas you can have. For example, the absolute value function is defined to be x if x is greater than or equal to 0, and it's the opposite of x if x is negative, because if x is like negative 5, the opposite of negative 5 would be 5. So how to write the formula and identify the domain and range of a piecewise function. So identify the intervals for which the different rules apply. Determine formulas that describe how to calculate an output from an input in each interval. And use braces and if statements to write the function. So a museum charges $5 per person for a guided tour with a group of 1 to 9 people, or a fixed $50 fee for a group of 10 or more people. Write a function relating the number of people, n, to the cost, c. Okay, so cost would be equal to, it's $5 per person for 1 to 9 people. So 5n if 1 is less than n, which is less than or equal to, less than or equal to n, less than or equal to 9. And then it's going to be just $50 for n greater than or equal to 10. That's it. I guess you can call it C of n. Okay. Next one, example 12. A cell phone company uses the function below to determine the cost C in dollars for G gigabytes of data transfer. So cost in terms of G is 25 if gigabytes used between 0 and 2, and it's 25 plus 10 times G minus 2 if the gigabytes is greater than or equal to 2. Find the cost of using 1.5 gigabytes of data and the cost of using 4. So the cost of 1.5 is going to fall into the first category here. So that's just going to be $25. The cost of 4 falls in the second category. So that's going to be 25 plus 10 times 4 minus 2. Or 25 plus 10 times 2. Or 25 plus 20, or $45. Okay. Now, how to sketch a piecewise function. Indicate on the x-axis the boundaries defined by the intervals on each piece of the domain. For each piece of the domain, graph on that interval using the corresponding equation pertaining to that piece. Do not graph two functions over one interval because it would violate the criteria of a function. Well said. So we're going to look at this. Oh, it's our last example. So the function is, the first thing we're going to look is at -4, then -4 to 4, and then so less than -4, between -4 and 4, and then greater than 4. So this is a cutoff, and this is a cutoff to 3 intervals. Now let's just look at, I mean, these are all linear, so if I were to put -4 in there, so our f of -4, it's going to be -0.5 times -4 minus 6. -0.5 times -4 is 2. 2 minus 6 is -4. So let me scroll this up a little bit. So this would be -4. And let's look at what maybe f of -8 would be. -0.5 times -8 minus 6. That's going to be +4 minus 6 is -2. So that would have been here, -2. So we're getting this line that comes down and stops there. Now for the next one, they just tell us it's -4 from -4 to 4. So from this point over to here, it's just -4. And I need to put an open interval here. I would put an open interval at this other point here on the left end, but that is the value of the previous function that happens to end there. Now let's look at this last one. Oh, no, I guess I can put a filled in circle, right, because it included the +4. Okay, for the last one, we're looking for x being greater than 4. So I'm going to put the boundary value in there. So f, hate to say it this way, f of 4 technically is -4. But I'm going to put this in here. So this is for, just to check, it'll be an open circle. So we have 1.5 times 4 minus 7. And 1.5 times 4, wouldn't that be 6? So 6 minus 7 would be -1. So this jumps up to -1 with an open circle there. And then we'll look at some other value on the interval. We can even look at 8. F of 8 would be 1.5 times 8 minus 7. So would that be 12 minus 7 to give us 5? So we're looking at here. And this is the line we're talking about. And that's it. I'm going to put an arrow here because it goes on that direction. It goes on in that direction, the arrow. Okay, hope that makes some sense. And now you're ready for the homework.